Good day, students. How are you doing? This is me again, Sir Navarro, and welcome to our video. So, in this video, we're going to continue with the analyzing the effects on the changes of variables or values in A, X, in A, H, and K. So now we are in the changes in H, right? And if the function given is in this form, so f of x equal to x minus h squared, quantity h, x minus h squared. So we're going to use the same function, alright? So the f of x equal to x squared. So this will be the parent function, okay? So we graphed this already in part 1. So now we let's consider these functions. Then we're going to use some values in x. No, these are just values I choose from randomly. Alright. So it's up to you what is from the domain, right? We know that the domain of a quadratic function, it's the set of all real numbers. So you need to say you can choose any of it. Right, so in this case, I choose these values. If you notice, they're not the same anymore because I choose to have or to have the vertex as the center, right? So that I can see the left side and the right side of the graph. So, anyways, moving on. So we solve the values of g of x by substituting this value. So what's the g of x? G of -1 is -1 minus 2, that's basically -3, then we square, that is 9, right? 0 minus 2, that's -2 square, 4, 1 minus 2, that's -1, then square 1, 2 minus 2, that's 0, square 0, and so on. Let's go to the second function. We have -6. Now the function is h of x equal to x plus 3 square. So -6 minus -6 plus 3 square, that's basically -3, and then if you square that, that is also 9. -5 plus 3, that is -2. Then you square 4. -4, and you substitute it here, that's 1 square. So that's 1 also. -3 plus 3 is 0, so 0 square, 0, and so on. So here, p of x equal to x minus 4, quantity x minus 4 square. So substitute 0 minus 4, that's -4, then square 16. 1 minus 4, that's what's that? -3, and then square, that's 9. 2 minus 4, that's -2, and then square 4. 3 minus 4, that's -1 square 1. 4 minus 4, that's 0, and then square 0, and so on. Alright, so yeah. So now let's graph each function step by step, not totally step by step, but yeah, comparing each function from using comparing each function to the parent function. So this is the graph of y equal to x squared, remember? So now we graph these points, no, sa functions at g of x. So here -1, 9, here 0, 4, here 1, 1, here 2, 0, here, and then 3, 1 there, 4, 4 here, and then 5, 9s here. So then you connect the dots using like a smooth curve, then this will be the image, right? So if you notice, there's some changes, no, based lang sa parent function y equal to x squared. Let's graph the other two functions. Then next, we compare these values. We have h of x equal to x plus 3 square. -6, 9, it's here. and then negative 5, 4 down here, negative 4, 1 here, and then negative 3, 0. So negative 2, 1, negative 1, 4, and then 0, 9 there. Then we connect it, and that's the graph of this function. Next, we graph the function p of x equal to x, quantity x minus 4 squared. So 0, 16, 9, 0, 16, it's here, 1, 9, down here, then 3, 1, down here, oh wait, sorry, 2, 4, sorry, 2, 4, down here, and then 3, 1, I missed some points, so it's 4, 0, and then we have 6, 4, then yeah, this one is just an extra, and also this one. So anyways, we have 3, 1, it's here, and 5, 1 down also here. So if we try to connect those dots, that's basically the image will exactly look like this. Alright. So by the way, when you are given this kind of function with the form f of x equal to x minus h, quantity x minus h squared, the vertex will always be, oh no, not that one. The vertex will always be h0. In the last video, if the function given is of the form f of x equal to x squared plus k, then its vertex is, the vertex will be, sorry, so the vertex will be what? So v, that's 0, k, alright? So here, it's h0, and then this one, 0, k. So meaning to say the vertex here is 2, 0. Need to get the opposite. 2, 0. Negative 3, 0. 4, 0. Alright? So these are the graphs. So if this is red, this is the graph of the g of x. H of x, this is the graph of h of x. P of x is brown. So this is the graph of p of x. So question is, what can you say about the implication of the value or the changes in the value of h? Right? What can you say about, what have you observed from the parent function y equal to x squared? What can you say with the other graphs? They have the same shape, no? They have the same size with the parent function y equal to x squared because they have the same value of a. The question is, what does h implies? What does h do have to do with the graph, with the changes in the graph? So if you notice, there are changes in the graph. In which part of the graph are there changes? Is it horizontally or vertically? Alright? So if you notice, the graphs are moved like left or right. Alright? Meaning to say there are movements along the x-axis. So to summarize, h has something to do with the movement of what? The movement of the graph horizontally, right? Either left or right. So in short, if h is positive, the graph, if you notice here, if our h here is positive 2, so this is the vertex, right? H is 2. If h is positive, the graph of y equal to x squared is shifted h units to the right, So if you notice, if we locate the vertex here, 0, 0, and then we count 2 units to the right, 1, 2, then this is the graph. This one, if we locate the point here, negative 2, 4, we count to 1, 2, then this is the point. And this goes and on. Same with this one, the negative. So h of x, diba? Our h here is negative 3. H is equal to negative 3. So we have to move to the left. So from this graph, 0, 0, 1, 2, 3, to the left, alright? To the left. Okay? Same with the other points, you can do that with the other points. Okay, so in this, if you notice in this graph, no, so if I change my h, no, if take a look at the movement of the graph. If I change my h, it moves along the x-axis, either left or right. Actually, this can go on and on, right? So if negative on the left, and if positive on the right. So I hope you get the point. Okay. So now let's proceed with this one. So the vertex of the graph is h0 and the axis of symmetry is x equal to h. Then now let's proceed to when they both h and k are present. Right? So in the function given is f of x equal to x minus h squared plus k. So this one. So similar functions earlier, but we only added the k. So I'm just going to solve one of the value. Right? Negative 1. That's basically negative 3. Then square 9 plus 1, so 10. Then this goes on. Also here, negative 6 plus 3. That's basically negative 3 square. So 9 minus 1, so 8. So 0 minus 4. That's negative 4, 16 minus 3, 13, and on. So now let's try to graph this function. So negative 1, 10. So down here, 0, 5, 1, 2, 2, 1, 4, 5, 5, 10. Right? And on. So we connect the dots. That's the graph. Let's go to the other function, negative 6, 8. So negative 6, 8 is here. Negative 6, 8 is here. Negative 5, 3. Negative 4, 0. Yeah. Negative 3, 1 down here. And negative 2, 0. Then 1 positive 3. I suppose that's negative 1. Yeah, negative 1, 3. Right? Yeah, let's check. Negative 1. Oh, wait. Yeah, so that's correct. Negative 1, and then we have 0, 8. Then we connect. Let's try to graph also this one. 0, 13. That's here. Oh, wait. 1, 6. Then 2, 1. 3, negative 2. Then 4, negative 3. I hope this won't be distracted. 5, negative 2. 6, 1. And so on. Then we connect. So if you notice, what happened to the graph of y equal to x squared? So these are their graphs. What can you say about their graphs when the function is y equal to x minus h squared plus k? What can we infer when h and k are present? Right? So in graphing this function, they have similar shape with the parent function, alright? So for example, this one, if there are changes in h, no, if you notice, there are also changes in along the x-axis. So for example, like the parent function has the vertex of 0, 0. Then the h here is positive 2, so we need to with the red one we need to count 2 units to the right, right? And then if there are changes in k also, there are changes along the y-axis. So if our k is 1, from this parent function, the vertex will be 2, 1, right? So there we need to move 2 units to the right and 1 unit upwards. Alright? And then this one, negative 3, our vertex is negative 3, negative 1. So we need to move 3 units to the left, 1, 2, 3, then 1 unit downwards. So that's how it is. Thank you and God bless.